It's pretty wild to think about, right? That a massive shift in how you see the world, something that can totally reframe your life, could all come down to one tiny molecular switch being flipped inside your brain. Today, we're going to get right into the neuroscience of it all and focus on that one tiny switch, the 5-HT2A receptor. This is the key that unlocks the whole psychedelic experience.
All right, so here's the game plan for this explainer. We'll kick things off with the big picture, this new wave of psychedelic research. Then we're going to peek inside the brain to see what's actually changing before zooming way in on that molecular switch itself. After that, we'll see how that tiny action leads to huge psychological shifts, explore the therapeutic promise, and then, we got to finish with a crucial reality check on where the science really stands today.
For almost 50 years, research into these incredibly powerful compounds was basically frozen in time, just completely off limits. But now, labs all over the world are finally picking up where science left off, kicking off what everyone is calling a psychedelic renaissance. And honestly, the results they're finding are just fascinating.
Now, this quote here is from Dr. Timothy Leary, who is, well, a pretty controversial figure for sure. But it perfectly captures the absolute power of the experience itself. It's this profound reality-bending effect that first made researchers think, whoa, okay, we might be onto something huge here about the human mind. But that initial excitement, it just came to a screeching halt. This timeline really tells the story. You see this burst of scientific exploration in the 60s, and then silence. Decades of it, after these substances were made illegal. It wasn't until the year 2000 that Johns Hopkins got the green light to start again, and their 2006 study, well, that was the spark that reignited this entire field of research.
So let's move beyond just what people say it feels like. What is actually happening inside the brain? Well, thanks to modern brain imaging, we can literally see the radical shift in communication that happens when someone is under the influence of a psychedelic.
Okay, so on the left, that's your brain on any normal day. It's efficient, it's orderly, you've got these distinct networks that handle specific jobs, like the default mode network, which is kind of your brain's autopilot, thinking about yourself, the past, the future. But on the right, under psychedelics, those boundaries just dissolve. The brain becomes hyper-connected. Brain regions that almost never talk to each other suddenly start chatting away. It's a more flexible, what scientists call an entropic state. And it's in this flexible state that the brain can forge new pathways, potentially breaking out of those super rigid negative thought loops we see in conditions like depression.
So how on earth does this happen? How does the brain go from orderly to that? The answer isn't in some big, sweeping change. It's in a single, specific protein molecule. Let's zoom way in and meet the star of our show.
First, a super quick science lesson. A receptor is basically a tiny lock on the surface of a neuron. It just sits there, waiting for one very, very specific chemical key to come along, fit inside it, and unlock a new instruction for the cell. Our brains are filled with trillions of these little lock-and-key systems running everything.
So here's the journey, and this is the crucial part. Step 1, you ingest psilocybin. Step 2, your body converts it into psilocin, which is the active compound. Now, this psilocin molecule is a master of disguise. It looks so much like our own natural neurotransmitter serotonin that it travels up to the brain and finds a very specific lock, the serotonin 2A receptor, or 5-HT2A. And in step 4, it slides right in, turns the key, and flips the switch that kicks off this massive cascade of effects we've been talking about.
Okay, so we've flipped the switch. Now what? Well, this is where it all connects. Flipping that one molecular switch doesn't just change brain connectivity, it fundamentally alters the very framework we use to understand reality.
Right now, the leading theory for how this works is called the rebus model. The idea is that our brains run on a set of high-level beliefs, mental shortcuts about the world and who we are. They're useful, but they can become incredibly rigid. Think about the deep-seated belief, I am worthless, in someone with severe depression. According to the rebus model, activating that 5-HT2A receptor temporarily relaxes those rigid beliefs, opening the door for new ways of thinking. And with those rigid beliefs loosened up, the brain enters that more flexible, more entropic state we saw in the brain scans. The usual top-down control gets dialed back, which allows new thoughts, new connections, and new perspectives to just bubble up from the bottom. This is that therapeutic window where real insights and emotional breakthroughs can happen. Okay, let's zoom all the way back out. We've gone from the whole brain down to a single molecule and back up again. So what does this potential to reset the brain actually mean for treating some of our most challenging mental health conditions?
The personal impact can be absolutely staggering. In that famous 2006 Johns Hopkins study, over 70% of the participants said their psilocybin experience was one of the 5 most spiritually significant and personally meaningful events of their entire lives. Just think about that, on par with the birth of a child.
And you can bet the scientific community has taken notice. That kind of profound personal impact has fueled a huge surge in research. As of late 2023, there were more than 134 clinical trials registered involving psilocybin, looking at its potential for all sorts of conditions.
And we are talking about some of the toughest nuts to crack in mental health here. Things like treatment-resistant depression, where nothing else has worked. We're also talking about PTSD, addiction, and the really deep anxiety that can come with a terminal illness. This isn't about escaping reality. It's about finding a new way to confront and reframe these deeply ingrained patterns of thought.
But, and this is so important, we have to separate the promise from the present-day reality. Despite all the exciting results, psilocybin isn't a magic pill. The path of becoming an approved medicine is long and it's incredibly complex.
So where's the research, really? Well, as this table shows, most of the studies so far have been pretty small. Phase 1 and 2 trials often have fewer than 50 people. They're mostly designed to check for safety and get early hints if something is working. We're only now starting to see the launch of those bigger, more rigorous Phase 3 trials, the kind you absolutely need to get something approved as a medicine.
The big takeaway here is patience. On average, a new drug takes over a decade to get from the lab to your local pharmacy. And for psilocybin, which is still a Schedule 1 drug, that path is loaded with extra regulatory hurdles, making the whole timeline even more uncertain.
So yeah, the road ahead is long, but the science is pretty undeniable. A single molecule, pretending to be one of our own, flips one specific switch that can temporarily dissolve the rigid structures of who we think we are and allow the brain to explore a whole universe of new connections. It really makes you wonder, if this is what one tiny switch can do, what other secrets to consciousness are just sitting there in our brains, waiting to be discovered?